Greetings, parasite ecologists. Today we're talking about the class Monogenea, which is an entirely parasitic class of flatworms closely related to another entirely parasitic class of flatworms, the trematodes. But while the trematodes have beautiful life cycles, the monogenes are just plain beautiful. Don't believe me? Stay tuned. As we go through this lecture, we're going to talk specifically about a couple of things that are important to remember about the class Monogenea. They're extremely, famously host-specific. They're really good at tracking their host through the environment, probably because they're very host-specific. And they really highlight the differences between macroparasites and microparasites. So here we are in the phylum Platyhelminthes, in the class Monogenea. These guys are parasitic primarily on fishes, and there are about 5,000 currently described species, which is only a little bit lower than the 6,000 or so described species of mammals. I say that just to give you some perspective. We care a ton about mammals, but there are only about 6,000 species of mammals on the planet. There are 5,000 species of monogenes alone, just a single class of parasite. That should give you some sense of how unbelievably outnumbered we mammals are by all the species of parasites in the world. Now, if you watched the trematode videos, the monogenes are gonna look pretty familiar to you. I told you the class Trematoda and the class Monogenea are closely related. Two big differences to notice. Most trematodes are gonna have both an oral sucker and a ventral sucker, whereas the monogenes just have the oral sucker. No acetabulum here. As in the trematodes, that oral sucker opens onto a gut tract, which is often bifurcated into two branches. Then you'll also find a lot of standard issue flatworm stuff. Ovaries and testes in the same individual animal because these guys are hermaphroditic, as well as organs like vitellaria for providing the yolk of any eggs that get produced. So far, monogenes look a lot like trematodes, but not so fast. What is that giant circle stuck onto the hind end of this flatworm? We've never seen one of those before. It turns out the monogenes have a special organ that you won't find on any trematode. This big posterior attachment organ is sometimes called an opistaptor, sometimes just shortened to haptor, and it's the most special part of any monogene. We'll talk more about why in just a moment. These guys have only one host in their life cycle, so unlike, for example, the trematodes, monogenes are not complex life cycle parasites. They have direct life cycles where they're moving from one host to another host of the same species, not passing among hosts of different species. They are ectoparasites, typically found on the skin, gills, inside the cloaca, and inside the nasal capsules of hosts. And the hosts are usually aquatic organisms. Here's the basic layout of a monogene from Roberts and Genove's Foundations of Parasitology textbook. And there are a few things that I want to draw your attention to. First, notice that this little guy has eyes. Not all monogenes do, but when they do, the eyes can detect light and dark, but not form pictures. The anterior attachment organs serve to help the monogene attach to its host, usually through the production of sticky substances. The pharynx is where food is ingested and then passed into the gut tract for digestion. Most monogenes have a bifurcated gut with blind ends, but you can see that in the species depicted here, the gut is a continuous circle. Monogenes have no anuses, so any waste comes right back out the pharynx. This diagram is set up to show you a clear view of the organs on the left-hand side, but in a real animal, you'd see vitellaria on both sides. That's the cloud of dots that you see on the flanks of the monogene. And the vitellaria, of course, produce yolk for the eggs as well as the shells that go onto those eggs. Note that these animals are hermaphroditic, so you can see both a copulatory organ, sometimes called a penis, as well as a vagina. When sperm is received in the vagina, it passes down into the seminal receptacle and on down into the ovary where it can fertilize the waiting eggs. Those eggs are then outfitted with yolk and shell and passed out of the body. Now, as I mentioned, the posterior end of a monogene is armed with this big attachment organ called an opistaptor or a haptor. When I first heard the word opistaptor, I honestly just thought it was a random bunch of consonants stuck together. But it is a real word that refers to this organ that is very finely tuned to attach to the host to which this organism is highly host-specific. The monogenes are incredibly host-specific. This is something that they are famous for. Let's take a look at just how host-specific these parasites are. On the x-axis, you can see the size of the host spectrum, which is also called the host range, or the number of host species that can be infected by a particular species of monogene. And this is a histogram, so on the y-axis, you have the number of monogene species that correspond to each size of the host spectrum or host range. What we can interpret from this plot is that there are a lot of monogenes that can infect only one host species, 134 total monogene species on this plot. There are many fewer that can infect 2 host species, fewer still that can infect 3, and so on and so forth. So the vast majority of monogenes have 1 host species, and that's it. If that host species isn't around, that monogene species isn't going to be around either. And there's a really good reason for this high degree of host specificity. That opistaptor organ, the posterior attachment organ, is finely tuned to the morphology of the host. This is one variant of the opistaptor from one monogene species, and you can see that it is armed with hundreds and hundreds of clamps that are prehensile and can hold onto the gills of the fish to which this monogene species is host-specific. Here's a different kind of opistaptor that's armed with an array of hooks and a suction cup-like disc, where it can sort of lay that suction cup down on the skin of the fish that it wishes to infect, and then contract it like this to both create suction and sink the hooks of that suction cup right into the skin of the fish, ensuring that the monogene is stuck tight onto its host. We can also see other kinds of prehensile suction cups, or even tentacles, as elaborations of this opistaptor organ. Because of this unique attachment structure, these monogenes fit like a lock and a key onto their host. The attachment structure reflects the underlying micromorphology of the host's skin or gills. And it's a part of the reason why this monogene might be really good at attaching to one species of host, but really crap at attaching to another. Now here's a different kind of opistaptor. This is the kind used by Gyrodactylus, which is an important radiation of monogenes. This is what Gyrodactylus looks like when it is using its opistaptor to securely attach itself to the gill of its fish host. And here's what that opistaptor looks like when you pull it off of the host. The Gyrodactylus opistaptor is armed with a lot of really terrifying hooks, including 2 big anchor hooks right in the middle of that opistaptor, and then a bunch of marginal hooks around the outside. Those hooks are just far apart that they hook right into the architecture of the gill, to which this Gyrodactylus species is host-specific. So there are lots and lots of different kind of opistaptors that you might find among the monogenea, and the reason that they're so diverse is that they are finely tuned, like a lock and key, to fit into one host species, and usually one host species only. Next up, we'll talk about monogene life cycles and what hosts they infect. I'll see you in the next video.